Greetings to all viewers. This is Professor Ankit Singh. In my previous lecture, we were discussing regarding the first type of sight distance, that is stopping sight distance. We looked at the factors affecting the stopping sight distance and then later on derived the formula for stopping sight distance. Okay. Now we'll move to the next type of sight distance, that is overtaking sight distance. If all the vehicles travel on a road at the design speed, then theoretically there should be no need for any overtaking. In fact, all vehicles do not move at the design speed, and this is particularly true under mixed traffic conditions. Okay, and here we need to note that in India we have mixed traffic conditions. Okay, there are different types of vehicles moving on our roads with different speeds. Okay, hence there is a need to overtake. Okay, in such circumstances it is necessary for fast moving vehicles to overtake or pass the slow moving vehicles. It may not be possible to provide the facility to overtake the slow moving vehicles throughout the length of road. Okay, so this facility of overtaking, we might not be able to provide this throughout the length of road. So what we do is we provide certain sections over where this overtaking operation could be taken under. Okay, in such cases facilities for overtaking slow vehicles with adequate safety should be made possible at frequent distance intervals. Okay, at some distance intervals we need to provide overtaking facility. The minimum distance upon to the vision of the driver of a vehicle intending to overtake a slow vehicle ahead with safety against the traffic of the opposite direction is known as minimum overtaking sight distance or safe passing sight distance. Okay, so what is this overtaking sight distance? It is the distance available to the driver who is moving at design speed, okay, to overtake a slower moving vehicle, okay, with no opposition or no hamper of safety from the opposite direction. Okay, so the opposite moving traffic should not affect the safety of this overtaking operation. Okay, that length of road or that distance required to overtake is known as overtaking sight distance. Okay, we'll try to understand this with a diagram. Okay, the OHD is the distance measured along the center of the road which a driver with his eye level 1.2 meter above the road surface can see the top of an object 1.2 meter above the road surface. Okay, so as we already studied in my previous lecture that the standard eye level of a driver is considered to be 1.2 meters above the road surface, and here what we do is we consider the obstruction height as 1.2 meter also. Okay, in the case of SSD what we used to do is the obstruction height or the object height that we consider was 0.15 meters. Okay, but here in OHD it is also 1.2 meters. Next, importance of or importance on which OHD depends. Okay, it is the factors on which the OHD depends: speed of the overtaking vehicle, overtaken vehicle, and vehicle from the opposite direction. Okay, so there are three speeds coming into play: the speed of the overtaking vehicle, which is nothing but the design speed of the road. Okay, the speed of the overtaken vehicle, which is the speed of the vehicle which is traveling at a slower speed as compared to the design speed. Okay, and the vehicle coming from the opposite direction. Now when we try to derive the formula for OHD, what we do is we consider the overtaking vehicle speed as design speed and the speed from opposite direction also as design speed, but the overtaken speed would be less. Next factor is distance between the overtaking and the overtaken vehicle. Okay, this is the spacing between the two vehicles. skill and reaction time of the driver. Okay, we studied about the reaction time of the driver through PIEV theory in my previous lecture. Okay, so if the reaction time of the driver would be more, then obviously the OHD would be more. Rate of acceleration of the overtaking vehicle. Okay, if the rate of acceleration is good, then the required OHD would be less. Okay, we can overtake within a small distance if the if the rate of acceleration is more. Gradient of the road. Okay, how will the gradient of the road affect OHD? Okay, it would not affect much because the gravity would have the same effect on both the vehicles. Okay, even when the gradient is upwards or the gradient is downwards, the gravity would be either acting against both the vehicles or with both the vehicles. Okay, so the momentum affected on both vehicles due to gravity would be same. Okay, hence the gradient will not have much difference. Okay, hence in the formula that we derive for OHD, we do not consider gradient. Okay, we will deal with this later on. Okay, now let us have a look at this picture here. Okay, here A is the vehicle which is the overtaking vehicle. Okay, and this vehicle is traveling at design speed V, capital V. Okay, and B is the vehicle, that is the overtaken vehicle, traveling at a slower speed. Okay, and here you can see the overtaking operation. Okay, and C is the vehicle moving in the opposite direction. Okay, so what we need to do is we need to find out this total distance. Okay, which would be d1 plus d2 plus d3. Okay, what is d1? D1 is the distance traveled by the vehicle A from A1 to A2, and d2 could be split as S plus B plus S, where S is spacing between A and B. Okay, and B is the actual overtaking time or overtaking distance. Okay, and spacing again S, and d3 is the distance traveled by the vehicle C from C1 to C2 when this operation is being taking place. Okay, when this operation is being taken place, the vehicle C is also moving, so it would also travel for some distance. Okay, as we discussed earlier, we need safe overtaking distance, avoiding any collision from the opposite traffic. Okay, hence we need to consider this distance also. So when we consider two-way traffic, this is one-way direction and this is the other direction. When we consider two-way traffic, hence the OHD would be d1 plus d2 plus d3. Okay, now we'll derive the formulas for d1, d2 and d3. The other condition is when there is one-way traffic. Okay, so there is only one lane or there may be many lanes, but the traffic is moving in a single direction, then the OHD required would be only d1 plus d2. We will not be considering d3 in that case. Okay, let us move ahead to the derivation. Analysis of OHD. The figure shows the overtaking maneuver of vehicle A traveling at a design speed and another slow vehicle B on a two-lane road with two-way traffic. Okay, we can see that here. Third vehicle C comes from the opposite direction. Okay, so here vehicle A is traveling at design speed, vehicle B is traveling at a slower speed than the design speed, and vehicle C is also traveling at design speed but from the opposite direction. The overtaking maneuver may be split up into three operations, thus dividing the overtaking distance into three parts, that is d1, d2 and d3. d1 is the distance traveled by the overtaking vehicle A during the reaction time t of the driver from position A1 to A2. Okay, So this d1 is the distance traveled by vehicle A, that is during the reaction time. Okay, when the vehicle A approaches the vehicle B and it travels at the speed of vehicle B for some distance. Okay, when it is, or when the driver inside the vehicle A is trying to find an opportunity to overtake. Okay, it will travel for some distance at the same speed as that of B. Okay, and that would be for a time of reaction time small t. Okay, d2. d2 is the distance traveled by the vehicle A from A2 to A3 during the actual overtaking operation in time t seconds. Okay, now this is from A2 to A3, so this would be d2. d3, it is the distance traveled by oncoming vehicle C from C1 to C2 during the overtaking operation of A t seconds. This is capital T. Okay, we'll derive a formula for this capital T later on. Now, vehicle A is the overtaking vehicle originally traveling at design speed v meter per second or capital V in kmph. B is the overtaken or slow moving vehicle moving with uniform speed Vb in meter per second or capital Vb in kmph. C is a vehicle coming from opposite direction at the design speed v in meter per second or v capital V in kmph. Certain assumptions are made in calculating the values of d1, d2 and d3. Okay, now let us look at those assumptions. It is assumed that the vehicle A is forced to reduce its speed to Vb, okay, the speed of the slow moving vehicle B, and moves behind it, allowing a space S till there is an opportunity for safe overtaking operation. Okay, I already discussed this. The distance traveled by the vehicle A during this reaction time is d1 and is the distance between A1 and A2. Okay, so distance between A1 and A2 for a time t and traveling at a speed of Vb, okay, would be distance. As we know, speed is equal to distance by time taken. Okay, so distance would be speed into time, so it is d1 equal to Vb into t. Okay, from position A2, the vehicle A starts accelerating, shifts to the adjoining lane, overtakes the vehicle B and shifts back to its original lane ahead of B in position A3 in time t second. This is capital T. Okay, A2 goes to the other lane, overtakes the vehicle and then comes back to the lane A3 in time t, capital T. Okay, the straight distance between A2 and A3 is taken as d2. The minimum distance between position A2 and B1 may be taken as minimum spacing S of the two vehicles while moving with the speed Vb. Okay, now this spacing S is given by an empirical formula which is given as S is equal to 0.7 Vb plus 6. Now this formula is used when the velocity is in meter per second. Okay, so when the velocity is in meter per second, the formula used is S equal to 0.7 Vb plus 6. Okay, if the time taken by vehicle A for the overtaking operation from A2 to A3 is capital T seconds, the distance covered by the slow vehicle B traveling at a speed of Vb would be, again the distance would be velocity into time. So velocity is Vb into time, capital T. Okay, so we know that B is equal to Vb into T and we know that S is equal to 0.7 Vb plus 6. Now what is D2? D2 would be the sum of B plus S plus S. Okay, so B plus 2S. Thus distance D2 equal to B plus 2S. Okay, this is in meters. Now the time capital T depends on speed of overtaken vehicle B and the acceleration of overtaking vehicle A. This time T may be calculated by equating the distance d2 to vbt plus half at square. Okay. Now this is one of the formulas given by Newton. Okay, we know that s, that is distance, equal to ut plus half at square. Okay, so we got this formula from there. Using the general formula for distance traveled by a uniformly accelerating body with initial speed vb in meter per second and a is the acceleration in meter per second square. Okay, so now what we do is we equate these two distances. We know that d2 is equal to b plus 2s, and we know the standard formula for distance. Okay, from that we get vbt plus half at square. When we equate these two, what we get is, we know b equal to vb into t. Okay, b equal to vb into t, and 2s is equal to half at square. Okay, therefore we can write t is equal to 4s by a. Okay, now this here is capital T. That's a spelling mistake or written mistake here. Okay, when you solve this, you will get capital T is equal to root of 4s by a here. Now this is the formula that we will be using to find out the value of capital T. So capital T would be equal to root of 4s by a, where s is spacing and a is acceleration of the vehicle. Okay, so now we know the formula for s, that is 0.7 vb plus 6, and d2, that is vb plus t plus 2s. Okay, this is nothing but b plus 2s. So now we have arrived at a formula for d2. Now the third distance, that is d3. The distance traveled by vehicle C moving at design speed v in meter per second during the overtaking operation of vehicle A during time t, capital T, is the distance d2 between position C1 and C2. Okay, so the vehicle C is moving at a speed v and for a time capital T. Okay, so this distance could be given as distance equal to velocity into time, so it is v into t. So we get t3 equal to v into t. Now the total overtaking side distance is OSD equal to d1 plus d2 plus d3, that is vbt plus vb into capital T plus 2s plus capital V capital T. Okay, now this is the formula that we will be using when the velocity is given in meter per second. When the velocity is given in kmph, the formula would become OSD equal to 0.278 vb into t, that is reaction time t, plus 0.278 vb into t, that is capital T, and plus 2s plus 0.278 v into t. Okay, now when the velocity is in kmph, the formula for capital T will change. Okay, it would be root of 14.4 s by a. Okay, and here the a, that is acceleration, would be in kmph per second, and the formula for spacing will also change. It will be 0.2 vb plus 6. Okay, in case the speed of overtaken vehicle vb is not given, the same may be assumed as v minus 16 kmph, where v the design speed is in kmph, and vb equal to v minus 4.5 meter per second if the v is given in meter per seconds. Okay, so the slower moving speed, if not given in the question, you can assume it as v minus 16 if the velocity is in kmph, and v minus 4.5 if the velocity is in meter per second. At overtaking sections, the minimum overtaking distance should be d1 plus d2 plus d3 when two-way traffic exists. Now for one-way traffic it would be only d1 plus d2. Okay, on divided highways and roads with one-way traffic, the overtaking distance needs to be only d1 plus d2 as no vehicle is expected from the opposite direction. On divided highways with 4 or more lanes, IRC suggests that it is not necessary to provide the usual OHD. However, the sight distance on any highway should be more than the SHD, which is the absolute minimum sight distance. So next let us look at what are overtaking zones. Okay, there are few zones that we provide for this overtaking operation. Okay, let us see what they are. Overtaking zones are provided when OHD cannot be provided throughout the length of the highway. Okay, when we are not able to provide the overtaking sight distance throughout the length of the highway, what we do is we provide overtaking zones at certain intervals. These are zones dedicated for overtaking operation marked with wide roads. Okay, here you can see this here is the overtaking zone. The desirable length of overtaking zones is 5 times OHD and the minimum is 3 times OHD. So this total distance or length of the overtaking zone is desired to be 3 times, or sorry, it is desired that the length should be 5 times of OHD, but a minimum of 3 times of OHD should be provided. Okay, and what we do is we also provide signposts here. You can see S1, S2, S1 and S2. Okay, now these signposts are provided at a distance of OHD from the start of the overtaking zone. Okay, and also at a distance OHD before the end of the overtaking zone. Okay, there are signpost 1 and signpost 2. Now what is to be written on this signpost? On signpost 1, overtaking zone begins, and signpost 2, end of overtaking zone. Okay, now this is about overtaking zone. Next, the third type of sight distance is sight distance at intersections. Okay, at intersections where two or more roads meet, visibility should be provided for the drivers approaching the intersection from either sides. They should be able to perceive a hazard and stop the vehicle if required. Okay, so here in this diagram you can see there are two vehicles, vehicle 1 here and vehicle 2 here. They are driving into an intersection. Okay, and the distance available for them to stop is D2 and D1. Okay, so if this vehicle spots any obstruction at this point, then the minimum distance it will require to stop is D2 without collision from this vehicle. Okay, and the same for this vehicle would be D1. Okay, if they do not stop within distance D2 and D1, then at this point they would collide. Stopping sight distance for each road can be computed from the design speed. The sight distance should be provided such that the drivers on either side should be able to see each other. This is illustrated in the figure. Okay, so this is the sight line or the line of sight between the two vehicles, vehicle A and vehicle 2. Now we need to design the sight distance at intersections to be used on 3 possible conditions. Okay, there are 3 possible conditions that the sight distance need to satisfy. What are those? Enabling the approaching vehicle to change the speed. Okay, this is the first condition. When this vehicle approaches the intersection, it should be able to change its speed. Okay, it should be able to lower its speed. This is the first condition. Enabling the approaching vehicle to stop. This vehicle should be able to stop within this distance. And enabling the stopped vehicle to cross a main road. Okay, if a vehicle is stopped at this point, then a sufficient sight distance should be provided such that it can cross this road and go to the other part of the intersection. Okay, so these are the three conditions that we need to satisfy while designing sight distance for intersections. Now in my next lecture we will move ahead with horizontal alignment. Thank you.